Hello and welcome back to my channel. This week's problem is about finding the blue area, and you can see it is made up by a square, and we've got a quarter circle inside that square and then a line going from the bottom left corner of that square to the middle of the top side of that square. Can you find the blue area? If you want to have a go at this problem yourself, pause the video now because I'm going to show you my solution in 3, 2, 1. Okay, so the first thing I would do, or wanted to do with this problem, was to put it on a set of axes, so x and y here. Now, the main reason I wanted to do this is to get two equations for the circle, or quarter circle, and the line, and then find out the point of intersection. So, the equation for the quarter circle is pretty easy. Well, I'm going to do the equation for the circle. The equation for the circle gives us, I'm just going to label those key points there for us, gives us x squared plus y squared equals 10 squared. Okay, now just to go back quickly to those points, I know that the top middle point is minus 5, 0 because this square has a width of 10. Okay, that's going to be important for the next part, which is finding the equation of the line. Now I've got 2 points there, minus 5, 0 and minus 10, minus 10. Okay, so I'm going to use those 2 points to find the equation of the line. I'm going to get the gradient first of all by doing the change in y over the change in x. And it doesn't matter which way round you do that as long as you're consistent with the y's and the x's. Okay, that will give us an answer for the gradient of 2. And then we're going to substitute that into the equation for a straight line, which is y equals mx plus c, to give us y is 2x plus c. Substituting one of those points, it doesn't matter which one, I'm going to go with minus 5 and 0. So we get 0 is 2 lots of minus 5 plus the c. So 0 is minus 10 plus c, so the c is 10. So that gives us y equals 2x plus 10 as the equation of the line. That means we have got two equations now. We need to find out where those equations intersect. So I'm going to substitute in for y into the equation of the circle. So I'm going to make it x squared plus 2x plus 10 all squared equals 100. I've substituted the equation for the line into the equation for the circle. Now we've got to remember this is for the whole circle, not just the quarter circle. So there will be two solutions. Obviously we have to select the one that is below the x-axis. Okay, so expanding that, we get x squared plus 4x squared plus 40x plus 100 is equal to 100. That gives us 5x squared plus 40x because the 100 on each side cancels. Then we can factorise out the 5x to get 5x brackets x plus 8 equals 0, and therefore the solutions are either x equals 0 or x equals negative 8. Now, looking at our diagram, we're not concerned with the one where x would be equal to 0 because that is where the straight line would be above the axes. So we want the solution when x is equal to negative 8. And that, to get us the y value, we're going to substitute into either equation, but the easier one is the equation of the line. So we do y is 2 lots of negative 8 plus 10. That will give us, when we simplify, y is negative 6, and I put that on the diagram there as well. Now once we've got that, we're going to go back to this diagram. And we're going to start to think about the distances vertically and horizontally to that point of intersection. So if we put these lines in, what that will tell us is that this height here is 6, because the negative 6 means it's gone down 6 from the top. So that height there on the top left of that square has to be 6. Now that must mean that the bottom left must be 4. And we can use the same principle to work out the lengths across the top, or the split of lengths. Now we know from the top right to the middle is 5, but we know from the top right to the red line, this point of intersection up here, we know that that must have a total length of 8 because our x is minus 8. So that means that this bit from the midpoint to the top of this red line, where it is vertical from the point of intersection, must have a width of 3, which then means this must be 2 because it's got to add up to 10. Now from there, what we're going to do is get rid of those coordinates. We don't need those anymore, and I'm actually going to introduce this line. Okay, that will be a radius of your quarter circle, and so that must therefore also be 10. Now I'm going to start to make this a little bit simpler by removing two of these lines in a second. But before I do that, I'm going to tell you what these angles are. So this top right angle, you may have just seen it up here. Now that is going to be made up by 6 and 10. Okay, so opposite over hypotenuse would be sine, so its inverse sine of 6 over 10 would be that angle. Now we're also going to work out this angle up here, and that angle we can make up by doing opposite again, which is going to be 8 over hypotenuse, which is 10, inside the inverse sine. Now we can simplify both of those to sine minus 1 of 3 over 5 and sine minus 1 of 4 over 5. We are then going to get rid of those lines and make this a little bit simpler to look at and to work out the areas of. And I'm going to label these areas A, B, which is going to be pretty easy to work out, and C. Now, section A, you might be able to see, hopefully you can see that it's made up by this sector here, and that's why we've got that angle, minus the area of this triangle. Okay? Now, B, that is just the area of a triangle, so that will be straightforward. And C, we're going to work out by doing the area of this trapezium, subtract the area of the sector. Okay? So let's get stuck into that. A is equal to the area of the sector minus the area of the triangle. Now the sector is the angle over 360 times pi times radius squared, which is 10. Minus the area of that triangle. Now that triangle has a base of 5 and a perpendicular height of 6, okay, as we can see at the side here. So it's base times perpendicular height divided by 2. That will simplify to give us this, okay, because 10 squared is 100, 100 over 360 is 5 over 18. We've got the pi, we've got the sine minus 1, 3 over 5, okay, and then minus that 15. From there, B is pretty easy to work out. That's going to be the width, which is 2, times the height, which is 4, and half it. That gives us a total answer of 4. And then C, we are going to do the area of the trapezium, like I said, minus the area of the sector. Now, the area of trapezium is half the sum of the parallel sides. So half the sum of 4 and 10 times by the height between them, which would be 8. And then we're subtracting the area of the sector, which is the angle over 360 times pi times by radius squared. Now that will simplify to being 56 minus this fraction, which we can simplify even further to 56 minus 5 over 18 pi sine to the power of minus 1, or inverse sine, 4/5. We then just need to add these three things together. So A plus B plus C is the total blue area, which is all these three things added together, which will give us an answer of 45 plus these two multiples of inverse sines, so 5 over 18 pi sine minus 1 3/5 minus 5 over 18 pi sine minus 1 4/5, which we can simplify to this by factorising out the 5 over 18 pi. So my final answer is 45 minus 5 over 18 pi times by all of inverse sine 3/5 minus inverse sine of 4/5, which when rounded is 30.8 centimeters squared to 3 significant figures. If you managed to get this question right, well done. If you had a different solution, please let me know down in the comments below. Now, all that's left to say is thank you very much for watching. If you enjoyed this video, please consider liking the video and subscribing to the channel if you're not already subscribed. There will be another video up here that you can click on to watch. Please do that. It should be one just for you. Thank you very much for watching. I will see you next Monday at 5 PM for another problem solving video. Until then, bye bye.